Okay, I'm going to show you how to change a repeating decimal into a fraction. These are the steps that you should have written down in class today. So again, there's 7 steps process. We do need to go through all 7 steps, and I will number them as I go along. So this is our repeating decimal right here, 0.16, so therefore that's what we need to focus on changing to a decimal. So step number 1 is to let x equal that. So x is going to equal the repeating decimal, just as easy as that. So again, these are interchangeable. If I have this, I can replace it with this. If I have x, I can replace it with the decimal. They are interchangeable because, again, they represent the same thing. Step number 2 is to find the number of digits that repeat. If we look here, this decimal technically is that 0.161616. So again, the 2 numbers that are repeating are 16. So therefore there are 2 digits that are repeating. Step number 3 says multiply both sides by the number of 10, or with the power of 10, with the number of the same digits as in step number 2. So step number 2 had 2 digits. 2, that should be zeros, my bad. So 2 zeros. What number has 2 zeros? And the answer to that question is 100. So therefore, because this has 2 repeating decimals, we're going to use 100. 2 digits, 2 zeros, 100. So step number 3, we're going to take this equation right here and multiply both sides by 100. So if I have this, it's going to turn into that. We can rewrite that as just 100x equals 0.161616 repeating times 100. Now, anytime you multiply a number by 100, that means that we're going to move the decimal. So this causes the decimal to move 2 times to the right. So this decimal goes from being here to being here. So that will give us 16.1616, so on and so forth. We can then rewrite that as 16.16 repeating, because this will go on forever. So that's the same thing here. So what we have done is we have taken our repeating decimal, multiplied it by 100, and we multiply it by 100. It takes the 2 repeating decimals and then shoves them over to make them a whole number. And then because it is still repeating and it goes on forever, then that 161616 will always be at the end here. Okay? So that right there is step number 3. Step number 4 says rewrite the decimal as a sum. Sum means as an addition problem. So I'm going to rewrite 100x equals. Now, if I take these 2 apart, this is like saying $16.16. I can rewrite that as $16 plus 16 cents, and it'll still represent the same thing. So again, all I did is I took the 2 together and broke them up into 2 pieces as individuals here. Very easy. 1 whole number and a decimal split up to a whole number plus a decimal. Step number 5 is to replace the repeating decimal with the x. So right here, x is your repeating decimal. So therefore, this right here represents x. So I have 100x equals 16 plus x. This represents 1x. There's always an invisible 1 in front of your variables, so that's a 1x. So remember, these 2, interchangeable. So therefore, if I have the decimal, it's the same thing as saying x. Step number, that was number 5. Number 6. Move x from the right to the left side using an opposite operation. Okay, so we want to move this right x right here on the right hand side to the left hand side. What operation is going on here? We have addition, and the opposite of that is, oh my gosh, subtraction. So I'm going to subtract 1x on both sides, because again, what we do to one side, we have to do to the other. These x's go away because a positive 1x minus 1x is 0. It's gone. Over here, we have 99x equals 16. So that was step number 6. Step number 7 is the very last step. Solve for x using opposite operation. So the operation that is keeping these together right here is multiplication. The opposite is division. So we're going to divide both sides by 99. 99 divided by 99 is a whole. And then we get 16 over 99. If you were to stick this into a calculator, again, you would get our repeating decimal, which is 0.16 repeating.